Looks like my robot assistant here is wanting a little attention. Would you like me to introduce you to the audience? Yeah. This robotic arm from Denso is more than just fun. Thanks to the efforts of Alliance member Imaging Labs, the robotic arm and everything you've seen it do this morning has been completely controlled in LabVIEW 2009. Now, robotics is just one of many unique applications we see at National Instruments. Every year, we sell to 30,000 different companies. So you can imagine, we see a lot of very unique and a lot of very innovative applications. And here you see one example. To tell us more about how they developed this innovative machine, please welcome James Carver and Yvonne.
Hello, John.
James.
Thank you.
Yvonne, thank you. Welcome to NIWeek. Tell us a little about your machine.
Thank you, John. This machine here is FIDEX, a novel trimodal veterinary imaging scanner and Animage's first product. Animage was founded just last year by Exim Computing Corporation, which has a worldwide reputation for advanced CT imaging software. Animage brings this technology to veterinary medicine, and JAMCO signed on to provide the mechanical design. FIDEX combines three completely unique imaging modalities into one inexpensive and compact scanner. This is one of our first images ever. Can you tell what this is?
Well, having spent a little money on family pets, I'd say it looks like an X-ray of a dog.
Better still, John, this is a digital radiograph, which is becoming the industry standard and what you would typically find in the better veterinary clinics. Radiographs, however, are pretty limited in what they can show. But FIDEX removes those limitations by providing the veterinarian with two additional imaging modalities. One of these is fluoroscopy, or X-ray video. Oh. This is alligatorus wind up as our first fluoro image ever. I told you this was a brand new product.
Yes.
But it's our third imaging type where FIDEX really shifts the paradigm. This is a feline. Can you tell me what type of image this is?
Come on, James. It's kind of obvious. It's a CAT scan.
Oh, man. That's right, John. But we refer to this type of image as a CT scan, which stands for computed tomography. FIDEX is a type of CT scanner that uses cone beam tomography, which is a way of acquiring the image as a volume all at once, instead of slice by slice, like with a conventional CT scanner. Now, computed cone beam tomography has some powerful advantages, like faster imaging, ease of use, and a more compact overall size. But computationally, it's a lot tougher to do.
So it sounds like some really impressive technology. Obviously, it's a great-looking machine. So I'm guessing it's taken you years to develop this.
Oh, man. It only felt like it, John. This is what our system looked like last January. And this is our first fully functioning prototype, which we produced in March. We came a long ways in a short time, John, and a lot of the credit goes to LabVIEW and CompactRIO. LabVIEW controls our X-ray camera, our I/O, and all 8 motion axes of our prototype. And the best part, when we completed our design, all of that code ported to the production machine using single board RIO without a single edit.
Very nice. But still, I mean, for the prototype that you had just earlier in the year, you must have had years of development for that prototype.
You know, that part didn't even feel like it. It was a lot of fun using LabVIEW, seriously. This is what our system architecture looked like about a year ago. CompactRIO and LabVIEW helped us to develop our product very quickly. And because we didn't have to redesign anything from scratch, except for a mechanical system here, we're making it to market on time, despite all the anxiety. Now, we estimate your product saved us about 3 man-years in development time, or about $300,000 in cost. To put it a little differently, I had one guy helping me with the mechanical design, and at Animage, we had Yvonne and Matt Antonelli to do all of the code and the electrical design. 4 guys, about 9 months, and look what we did.
Very impressive, guys. Well, thank you very much for sharing your story, your machine.
Thank you, John.
Good luck. Thank you, Yvonne.